Hi everyone, welcome back. Hopefully you got a quick break. We're able to condense your notes. I know that was a ton of content we threw at you, and we're about to have some more really great content. As a quick reminder, please keep all of your questions in the Q&A. That really helps our panelists stay organized, and also we're able to export those after the fact in case you had a unique question or we need to get in touch with you after. But feel free to put in the chat anything fun or things that our panelists don't have to keep organized. And with that, I'll kick it back over to you, William and Ronak.
Appreciate it. All right. I'm gonna do everybody a favor and try to talk less this time than the last one. Let me first share the correct screen. I think this is it. So this session is all about security. Very quickly, when it comes to Kubernetes security, like upstream Kubernetes or open source Kubernetes, this is really top of mind for everybody in the community. And obviously, there's like a lot of enhancement and work that goes into this. So VKS is at its core, it's upstream Kubernetes, right? The actual cluster itself is upstream, which means all the innovation and things that happen from the upstream project fully apply to VKS. So best practices in regular Kubernetes are we're just kind of saying like they're a given. Very quickly, I'm going to talk about a few of them. Realistically, it just means if you're familiar with the terms, um, we need RBAC or role-based access control, and we have network policies. So RBAC, same RBAC as everything else. Who you are, what do you have authority to do, and how much of it can you do? And the network policies are more so think of them as like firewalls. And basically, when you have this kind of separation in these tenants within a Kubernetes cluster, you can say something like nothing in namespace 3 is allowed to communicate with any namespace outside of namespace 3. Or you could have, all right, my payment needs to access a database. So if they're living within the same cluster, I can say namespace 2 can talk to namespace 3, but absolutely nothing else. And that tends to be where like most, if you're not using like a vendor's distribution, that tends to be like where you stop. Because that's fundamentally like the easiest and best practices and kind of there's other things as well, but that's the majority of it. So again, that's fully supported in VKS. What we're going to talk about is what's beyond upstream Kubernetes and what's unique about VKS and VCF and some other aspects of Broadcom software portfolio. So the first concept we want to talk about is tenancy. And then tenancy is basically it's RBAC, right? And security is good to think about in context of the OSI models, right? So layers 1 through 7. This tenancy stuff is typically not really. You can kind of say it's layer 4 because like network access, but realistically, it's kind of Kubernetes RBAC extended across more constructs. So when we talk about tenancy, let's just say we have like a vCenter or like a typical ESX estate. If you've seen Will or me or anybody else do this, we have a component called the supervisor. This is basically the cloud API that turns like a typical VMware environment into a cloud native platform. Okay. Then under the hood, your supervisor is a Kubernetes cluster. So all of those things in context of RBAC and whatnot, and resource quotas and all that good stuff, you can actually bring in to your cloud VMware estate. So what that means is, just like Kubernetes namespaces, we have vSphere namespaces that you can use to kind of partition your cloud infrastructure. And then these, like this is basically RBAC plus quotaing. And then you can say, like, in this cluster, you can create VKS clusters, but the only person that can deploy things into here as well, right? Like Ronak's not allowed to touch this namespace. So inherently, there's a lot of just kind of decreasing blast radius and the like how bad incidents can go directly into this. This is full kind of isolation down to the hypervisor itself. So if you break into one namespace, it's very hard to get out of it. It's really hard to get into another namespace. So that's kind of the first aspect of it. And then this is you don't need anything outside of basically vSphere to do this, right? And then as you kind of layer on additional components of the VCF stack, you would get more and more functionality, kind of achieve better security posture. We're going to talk a lot about this one, but VCF automation tends to be a very good kind of next step. And a lot from a Kubernetes perspective, a lot of our customers that care about VCF and Kubernetes, VCF automation tends to be a very natural progression of like what's the next component in the stack they use. And we kind of take this concept of tenancy and expand it even more. If anybody in the audience is familiar with VCD or vCloud Director from before the acquisition, a lot of those concepts kind of apply here. But essentially, what we do, we have organizations. Again, this is RBAC, right? So who's a part of this organization? What can they do? How much of it can they do? Under an organization, we have projects, just more of the same, right? But then these projects are all under one organization, so on and so forth, right? And then under these projects, we actually have a region. And let's just draw out two regions. And it's a little confusing to kind of draw out, but then these projects aren't like one to one. You could have a project that actually impacts multiple regions, so on and so forth. And at the end of the day, like this is all logical constructs. So these regions all tie back to a supervisor. And then if anybody's kind of curious, like you can have multiple supervisors in a vCenter, like you can have multiple instances in your fleet, so on and so forth, right? So like the flexibility of your tenancy model is kind of the permutations are infinite. If there are questions as it relates to how you should set this up, I very much encourage you to reach out to your account team because every customer is going to be kind of different. So that's kind of the tenets of it. Now, again, this is all RBAC. One kind of crucial thing that we're not going to spend too much time on, if we just don't have that much time. VCF automation ties really well into VCF networking or NSX. And if you're not familiar, one of the newer features in VCF networking is virtual private clouds, right? So when we're talking about the OSI model, layer four, you can have that kind of segregation within each one of these vSphere namespaces. Because if I have these VKS clusters, I can then encapsulate them effectively inside their own network using VPCs. VPC 1, and that just provides even more flexibility as to what you can do and how realistically we all know how we can comply with our security friends. So well, that's the crash course on this stuff. You got some more interesting things to talk about for sure.
All right. Okay. Let's see here. Where did my board go? Share. All right. Do I have the right thing up? Yes. Okay. All right. So, a couple things we're going to cover in the next few sections of this are going to be um, a bit more on VCF automation and VKS and kind of how those tie in and some things around authentication. I did see a couple questions out there. Maybe we'll just address those real quickly. A region is unique per supervisor. Question would be, so a supervisor, so basically what that looks like is you have, our screen sizes are so different, Ronak, that I have to like zoom
Oh, is
in.
that what's going on?
Yeah,
Okay.
that's why when I draw, it's a lot smaller. It's funny. Um, so what we end up with from a region perspective is you have a region which is defined inside of VCF automation, right? And then a supervisor is part of that region. I believe it was in 9.1, we introduced the ability to have multiple supervisors in a region. So you can have kind of a setup like this, and then that supervisor has zones attached to it, right? You can have multiple zones for each supervisor. Um, And these zones are effectively vSphere zones, which map back to ESX clusters. A zone can also have multiple ESX clusters in them. So that's kind of what it looks like. So when you target a region um, with a namespace, right? So when you deploy a namespace from VCF automation, what Ronak was just showing is you say a namespace is going to be part of a VPC, and it's also going to be part of a region, and it's also going to be part of a zone in that region, right? So when you create that namespace, it figures out the actual infrastructure that it needs to land on through these details of the namespace creation, which will land the namespace on a supervisor within the correct compute area. So hopefully that makes sense. Um, Then another question, how is this impacted with NSXT VPCs and Avi? So there's a bit of detail involved in how that all works. We probably can't go through the full in depth of all those pieces, but NSX plus Avi full integration works. Actually, the lab I have that I'm going to show you some live demos in has Avi plus NSX plus VPCs all in use. So essentially what happens is you have a VPC, again, pretty high level here. Your VPC is going to have an Avi SE deployed or SEs deployed into it onto a network. And then that's going to be called like a services network. Then you're going to have your clusters, workloads, etc. over here on another network within the VPC. And Avi, like your VIP essentially, is going to come into here and then it's going to be able to route it across. So that's kind of how it works within NSX and Avi networking. Again, lots of layers kind of missing from this diagram, but this is effectively the meat of it, which is Avi SEs live on a network within the VPC.
And then there's like more questions coming about Avi and NSX and stuff. I think let's kind of continue
Yeah.
with this because what we're gonna go into is gonna help, but like unfortunately that's a pretty it's a complicated topic. It's just gonna require more time than we have. Highly recommend that reaching out to your account team. They can even get a set like Will and I or somebody else on our team can come and chat with you guys and your particular use case as well.
Yeah. I'll just answer the last one on here really quick on VNA. The VNA component of this, uh, VNA handles load balancing and NAT when you're doing distributed transit gateway. Um, and when you introduce Avi into that, VNA is bypassed. Avi handles load balancing. VNA is used for NAT. Okay. Uh, I'm not sure. There's a lot of a lot of comments coming into the Q&A. It seems ALB. When you say ALB, I assume you're talking about Avi, and Avi absolutely supports VPC.
And really quickly, there's some VPCs and fleet kind of questions. Um, the a virtual private cloud um, is an NSX construct, right? So typically, what we do when we think about VPCs, think of how in hyperscalers, before you deploy things, you typically need a virtual private cloud, right? We deploy things into ultimately a vSphere namespace. So most of the time, we recommend using VPCs inside a vSphere namespace. So no, we wouldn't have multiple fleets. We would just have the VPC inside your fleet.
All right. Okay. So I'm going to uh, talk about a little more in depth here on VCF automation and how that relates to some of the VKS components in a security landscape. Right. So VCF automation has something in it called cluster management. If you were familiar with Tanzu Mission Control in the past, um, a lot of those transmission control capabilities have been moved into VCF automation underneath cluster management. So it's all native and integrated. So when you bring VKS in, right, you've got your VKS clusters down here that are kind of running out in your infrastructure. When you deploy a VKS cluster, it automatically attaches into cluster management. It's just kind of a native process that happens, which means you get a bunch of capabilities from cluster management. Cluster management, in this case, the one I'm going to specifically talk about is policy, right? So from this policy layer, you can push down a bunch of different things into these clusters, right? So when you're looking at this generally at a security lens, it's kind of like, okay, I've got my initial RBAC set up within VCF automation. That's who can access the projects, who can access the orgs, who can do all of that kind of stuff. Um, then people start creating clusters. Maybe you're doing self-service, that type of thing. So you want to make sure that those clusters that come up are also going to have like a base set of rules enforced. So that might be things like pod security, right? There have been many iterations of pod security over the life of Kubernetes, but no matter the implementation details, a lot of the things have stayed the same, which is you want to prevent containers from running as root or restrict host networking, stuff like that, right? Things that you don't want to have users just generally able to do when they deploy a pod because it could break out of the kind of containerization constructs and become root on the actual underlying system. So through cluster management, you'll be able to enforce pod security, and we can do all of this at the org or project level, right? So when these clusters come up, for example, this cluster is going to live within an org and a project, right? So we'll just put project here to kind of make this show that this is a project. This cluster lives in a project. When we assign a policy to our project, it's going to automatically roll out to any cluster within that project, right? So now when people are deploying clusters, we're by default saying, hey, you cannot deploy root, like containers using root as their user. You cannot override to host networking, any of these. There's a big list of pod security things you can implement here. We can also do other policies like image registry policies. So in this case, like maybe you want the ability to restrict where images are being pulled from, specifically to, as an example, the prod registry in prod, right? You don't want a situation where you have clusters being spun up in production and pulling images from dev because your dev registry could potentially have less policy on it that allows an image with some undefined workloads to be pulled into your production cluster. Or if a bad actor gets into your cluster and can pull directly from Docker Hub, well, that's a big problem, right? So these registry policies can prevent any of those type of situations from happening. Pause there real quick. Any questions I'm missing, Ronak, or things you want to inject here?
Nope, nothing so far.
All right, cool. Some other policies in here. You can also do custom policy, which is probably my favorite of the bunch, which is the ability to write your own policy within this. We use Gatekeeper and Open Policy Agent behind the scenes to enforce these policies. So this lets you write your own Gatekeeper policy and push that out again, kind of like, I'm not going to use the word fleet here, even though I want to refer to all these clusters because it gets confusing with our, overall fleet. So I'm going to call these clusters like your, project level clusters or org level clusters. Maybe we'll come up with a good name for that to not overlap. But anyways, the point here being that anything you put into this policy section can be done at a more global level rather than applying individually to it every single cluster, right? And these custom gatekeeper policies in this case, you could enforce anything you really want here. Like if I wanted to enforce that no one can use a load balancer on port, I don't know, 5353, make up some number, right? You can get to that level of detail that you can enforce policy um, within the cluster. Any API level constraint is really what I'm saying there. Okay.
There's a question about policy and Git and using it as code. Like, absolutely, right? Like to do this
Yeah.
at scale, that's kind of the point of doing anything as code. So
Yeah.
yeah, 100%.
So in the next session where we dive deep into GitOps, we'll absolutely talk about some of that. But just keep in mind, everything I'm talking about right now can be done via a GitOps driven process, right? Through code, through Terraform, through Argo CD, all of those types of things.
Yeah. And then there was a question about like, can this or realistically anything that we're talking about, does it apply to other like Kubernetes distributions? The answer is just like as an umbrella, no, right? Like anything we talk about today is exclusive to VKS. And like this is why customers want to use VKS because we have kind of built like the way I like to talk about it is um, this entire platform is built by platform engineers for platform engineers, right? And this is why this solution is very attractive for our customers.
Yep. Um, yeah, exactly. Okay, so next kind of piece of this whole thing is going to be uh, like authentication into the clusters, right? So we've kind of gone through tenancy with VCF automation. Uh, we've gone through policy applied to clusters. Now, what about somebody getting access into that cluster? How do they actually log in? How do they deploy things? All of that. Now, you can put asterisks around all of this and say, like, as you progress in your Kubernetes journey, people may not be logging into clusters often, right? You have GitOps and other processes in place to kind of make things automated, but at any point in time, at least an administrator might need to log into a cluster to do some troubleshooting, right? So when we deploy clusters, and I'll talk about this kind of, I'm going to separate this diagram because it applies both to the VCF automation layer as well as just generally VKS, right?
Oh,
So
and very quickly before you move on, Will was talking about like the image registries and stuff. Um, registry has a lot of kind of security considerations when it comes to it. And most solutions that you use are going to have things built in. VKS and VCF, we ship a native container registry. It's called Harbor. Harbor tends to be kind of the most common one we see, particularly as it works for hosting AI models as well. So great choice. And again, like VKS and VCF basically has nearly everything you need in one bucket to deliver everything you need from day zero to day n.
there's also a question in chat about migrating. Um, so migrating VM apps to all apps. So when you deploy VCF automation, you and you like import an existing ARIA automation, let's say, you'll have a VM apps. You can have side by side with that in 9.1 and all apps, right? So 9.1 introduced the ability to run basically all apps and VM apps against the same vCenter side by side, right? So the same workload domain having both, which then will allow you to kind of do that migration as you please. Like there's not an auto migration from VM apps to all apps because there's some differences there, differences in how you work, things like that. But you can run them side by side. You can port things over, and then for I think since probably one of the 8.0 U3 releases, you've had the ability to import virtual machines from a traditional virtual machine into a supervisor managed VM service VM. So that goes along with that because in all apps, that's how we manage VMs. So hopefully that answers the question. If you want to go deeper on that, just reach out to, your account team and get everybody connected up. All right. So authentication, right? So when you deploy a supervisor and you deploy a VKS cluster, the supervisor itself will has basically vCenter SSO automatically wired into it, right? So that means whatever like AD or anything back there that you have automatically gets translated down to this VKS cluster so that that AD user can log in to the VKS cluster, right? So this is a like out of the box functionality. This has existed for a long time, but effectively, this is kind of like, you know, admins and others. This is how you initially can log into the supervisor, log into a VKS cluster, all those types of things. Now, we also have this option to enable OIDC, which goes alongside vCenter SSO. It's not a replacement for it. Both of these can live side by side, but this lets you bring an OIDC provider of some kind, like an Okta or Ping or whatever it might be, to the supervisor. And again, all of these SSO configs get propagated automatically to all of the Kubernetes clusters that you're creating, all the VKS clusters, right? So this means that by default, out of the box, if you're doing like vCenter SSO with Active Directory, you can give out access to your Kubernetes clusters to AD users without having to do any additional config, which is pretty cool. And then if you want to bring your own OIDC, you just wire that up once to the supervisor and it pushes all those configs to the VKS clusters. Now, the piece that also has to come into here is RBAC around this, right? So you've got your authentication piece here, but we also need the authorization piece of it, which comes in with Kubernetes RBAC, right? So we can push out some of this through the supervisor through built-in roles, right? There's a number of built-in roles inside of here, like cluster, editor, and some other things like that that can be pushed out. But you can also just generally push Kubernetes RBAC into these clusters for very specific roles, right? So if you wanted to have like a role developer where a user only can, access certain namespaces or something like that, you can push that into here, and this role can reference your SSO users, right? So all of it is integrated in a way that you effectively just apply your OIDC or SSO once into the supervisor, and all clusters will get that propagated down. So you don't need to go into every cluster and start, modifying your SSO configuration and setting up OIDC and doing all that stuff.
Hey, Will,
Yeah,
we're getting really close, and secrets and Avi and vDefend are very interesting. You think we should use a little bit of the GitOps time to
we
cover
we have 20
secrets and
minutes.
do we? Oh, all right, my bad. Keep going. I can't keep track of time.
Uh, I think. Do we? No, we. How long do we
Eric,
have?
you have an idea when we end? We started 3:20, right? So we got
10
we
after.
got
Yeah.
10 after.
Okay.
Oh, we got
Okay.
time. We got time.
Perfect. All right. Okay. So VCFA on top of this, right? Just to tie this in real quick. VCF automation, again, wires into this. What it also does is automatically set up OIDC. VCFA itself is an OIDC provider. This is a pretty big deal in my opinion because it allows for a lot of really interesting things to happen. So this OIDC, I'm not even going to draw that there because it'll be confusing. VCFA itself, being an OIDC provider, means that you can, when you connect these two, it automatically wires itself into the supervisor as OIDC so that whatever SSO provider you push into your tenant inside of VCFA automatically gets wired through here. And we also push project level permissions, project level roles also get pushed down to this as well. So it's just one more kind of piece of that integration that happens out of the box to make sure that any users that are logged in here with their roles get access to the right clusters and do it with an identity that isn't some random certificate or basic auth user. It is actually their identity, right? Okay, so next piece here, because we've got two more components of this, which I think we can spend about 7 minutes on each. Secrets. Secrets are the usually like one of the biggest topics from a Kubernetes standpoint of how do applications get secrets specifically in this case, right? There's a whole secrets management and system around fleets and all that kind of stuff. What we're going to be talking about is at the Kubernetes layer. How do people get secrets into their applications? Which kind of follows along with this, right? Once a user has access, they want to deploy an app. Now they need to get a secret for their app. So,
Also, really quickly, sorry, like
yep,
secrets are a little, it's like an umbrella term. Anything that should probably be private and not hard coded, you can kind of think of as a secret, right? This can be passwords, this can be things like IPs or just like how to access endpoints. This can be APIs, API credentials, tokens, authentication stuff. Like, again, anything that would be better off not being clear text can and should be stored as a secret. And you can kind of see why this tends to be like a really, really big topic of conversation because you have secrets at multiple layers. Like obviously your applications, the services that make up these applications, but then your platform and the services and the platform level applications that you use to provide services. So tends to be something you need
yep,
to solve for.
exactly. All right, so uh, back to the supervisor, common theme in a lot of these drawings. Um, with the supervisor, we have something called secret store. Secret store service. This is a fairly new service, I'd say, since 9.0 release. Um, and excuse me, what it does is behind the scenes, this actually deploys OpenBow. OpenBow is a fork, uh, open source upstream fork of HashiCorp Vault. Just like Terraform was forked into OpenTofu, OpenBow is the equivalent for HashiCorp Vault. Due to licensing issues, et cetera, people have started using OpenBow. Now, that means we also can ship OpenBow as part of our secret store service. There's a couple other components that are involved in this, but this is the core secret store. So we're not creating our own secret store. We're not creating our own like API to manage different secrets. OpenBow is effectively the HashiCorp Vault API.
It's also worth saying that like yeah, we provide something that fulfills all of these needs, but you don't have to use our stuff, right? Like if you are a HashiCorp Vault customer, that's totally fine.
Yeah.
You can integrate with this stuff. You can use just that. You can use Vault and Secret Store to fulfill like a larger blast radius of things that you need done, so on and so forth.
Yep. But one thing the secret store service does do, because it's integrated into here, right? There's kind of a theme here around integration. And like I typically talk about this with you look at something like EKS, people use EKS because it integrates with the broader ecosystem of AWS's services, right? Same thing goes for VKS. We have integrated services like Secret Store Service that are going to automatically create roles inside of OpenBow, right? So we're going to get roles automatically created when clusters get created, so that this cluster can talk back to the secret store service, aka OpenBow in this case, and pull secrets automatically. We don't have to pass credentials around. We don't have to do anything. We utilize the Kubernetes authentication method that's built into OpenBow to make this work. And we automate that through our secret store service, knowing about Kubernetes clusters being created and injecting the correct roles, paths, etc. And then also what we do is enable a separate API called key value secret that allows us to create secrets directly in here in a declarative way, right? Using simple YAML, which in kind of the standard upstream HashiCorp Vault, you're using a CLI, you're using an API, something like that to create secrets. We've made this so that you can simply do this from something like VCF automation, right? So if I jump over here real quick and log into my VCF automation org, and I go to one of my namespaces, you'll see the secrets tab here within the namespace. I can create a new secret, test, new. Behind the scenes, this is just generating basically a YAML file for the API and create. And now I've got a secret bound within this namespace that any clusters that I choose through my policies and roles, that there's some default ones auto set up, will be able to now pull a secret from this secret store into this cluster. I mean, generally, this is quite a large process of setup of a secret store, create your roles, create your policies, set up Kubernetes authentication for every cluster that gets created, all this stuff. All of that just happens for you so that these secrets can automatically be pulled into that cluster. And you can do that using a couple different ways, right? You can use external secret operator, ESO, which is probably the most common way to do this because it integrates directly. You can also use, we ship the Vault agent injector out of the box, which allows you to inject secrets directly into pods through file system mounting rather than Kubernetes secrets if you're more interested in that. And it's also worth noting this works for VMs using the VM service, as well as for pods using the container service.
And like, as you can kind of get the gist of it, this is pretty complicated. And it's far more complicated when you're doing it without our tooling. And having to stitch this together for a bunch of different ecosystems. For example, using something like a HashiCorp Vault and then doing it on Rancher that's separate from your vSphere estate, like that's a lot to maintain, and that tends to lead to anti-patterns such as giant clusters or sharing a whole bunch of applications. These kind of things that overall increase the risk across the enterprise. So the fact that all of this is effectively automated, available within the platform, and supported by us is, again, just going back to our first topic of conversation, a big reason why customers, whether they're just getting started with their Kubernetes journey or customers that have been doing cloud native for 10 years and kind of figured all this out themselves, like there's something in here for everybody that delivers value for what they're trying to achieve, which is deliver a resilient, scalable platform for their applications.
Yep. All right. So, last topic kind of on the security front here. And this one gets into network security, right? So we've covered basically tenancy, we've covered policy, we've covered authentication, authorization, we've covered secret management. Now, how do you protect those workloads, both at like the, I guess through all layers of the stack, right? So what we're going to introduce here is vDefend, right? If you're not familiar with vDefend, I probably don't have the time to cover what vDefend is, plus everything else in the next 10 minutes. But what it's going to allow us to do is create software-defined firewalls, right? vDefend has existed within NSX for a long time. You've probably seen it as, the DFW inside NSX and things like that. But this
If you
really
ever heard of
kind of,
microsegmentation, that's vDefend, right?
yeah, exactly. Um, but we're going to talk about this specifically in the context of using it with VKS, right? So we've got our VKS cluster down here, and Kubernetes has built-in network policy. But that network policy API is it's implemented at the CNI layer by any CNI in any cluster, but it's somewhat restricted in that like you have to create them per namespace. It's a kind of tedious to manage. So with vDefend, what we've been able to do for a long time is do distributed firewall rules for things like virtual machines, right? Who can talk to what, microsegmentation, all this kind of stuff. Now, how do we take that and apply that to an actual set of containers within a cluster? Um, so what we have inside of our clusters is something called Antria. Antria is a CNI, container network interface. It's open source. It is super performant, all the things, right? We are a maintainer of Antria. But what we've done is integrate from a vDefense standpoint with Antria. So Antria can actually integrate directly with vDefend, which is going to allow us to first visualize all of our cluster objects inside of vDefend. So you can see all your pods, services, etc. inside of vDefend. And then from there, what it's going to let us do is build groups and write distributed firewall policies, right? So we can take those objects, we can write rules and policies based on groups of pods, etc. So, policy like I want pod one to talk to pod two. I don't want anything to be able to talk out to specific sites on the internet, all of that stuff, right? Any policy you can think of being able to talk pod to pod or anything like that, we can do here. Um, and this pushes this down into the cluster. And it does it through Antria. And it also uses some cool functionality within Antria of being able to have this layered firewalling policy so that once these rules are pushed out, right, we end up with our actual like network policy inside the Kubernetes cluster. Um, these policies also cannot be changed by users in the cluster because of the level that they're categorized within Antria. So this allows admins, network admins, security admins, whoever's kind of controlling this policy to be able to push out this global, more top level policy within VKS so that they can create a baseline of security within the cluster, right?
This tends to be really like most organizations. Sorry to cut you off, Will.
You're good.
Um, they have like a central security team, but the security team is almost always they're not like Kubernetes experts. So they have a they have this general idea of like, okay, from a policy perspective, we have to make sure like X, Y, and Z happen. But how do I actually execute and how do I audit and how do I make sure that X, Y, Z has happened is impossible, right? That's the enforcement, that's the auditing, and that's what keeps everybody's jobs safe, and that's what keeps the enterprise safe. So this tends to be like the shortest way to do that because this basically abstracts the complexity of rolling this out at a cluster level using Kubernetes itself and does it via a different platform, different APIs, or a different UI. And then also, vDefend itself, it's worth talking about. Like, obviously, the platform, the solution lets you do all of this stuff, but it also gives you ideas, it gives you suggestions of rules, and it gives you suggestions of actions you can take within the platform that restrict what can happen in the case of a security breach, right? So it's like a predictive tool, it's a suggestion tool, and it's an enforcement and it's an audit tool all at once.
Yeah. And just to kind of build on this a little bit, we can also have these different layers of enforcement, right? The platform team might need to enforce some specific rules inside the cluster that are outside this admin enforced. And then from a developer perspective, the developer might be using something like Istio inside their cluster, right? Which is another component we support and ship. Um, and they might want to do MTLS between applications, right? So they can do MTLS enforcement here, then platform team enforcement, and then admin enforcement. They can all be layered on top of each other. Um, there's a question. Avi WAF is first step, and second step would be vdefend with ATP. Yeah, exactly. Right. Um, so what the next topic we'll cover here in about 2 minutes is going to be how Avi layers into this as well. Right. So when you have an application inside of here, right, the network policy is going to cover a lot of the east-west communication, things like that inside of the cluster. But how are you covering the ingress within this cluster, right? And that's where Avi comes in. This is obviously an optional piece here, but if you're using Avi, you should know this exists, and you should know this is a good security option as well. Avi is going to support handling ingress to applications inside of clusters, just natively out of the box. And what it also supports is wiring in WAF policy directly via Kubernetes into this, right? So I actually have this running right now in my environment where I have this application up, and this is routing through Avi into a Kubernetes cluster in an app running on a VPC. And I can do something like test here, and then let's just do like a SQL injection, like select star from users where, and
You're
it's
not signed in yet. I
yeah,
was
that was I didn't mean to be. So
got it.
what we'll see happen on the Avi side of things, and I don't know if I typed that correctly, but if we look at this virtual service, this is my actual Avi gateway. If we look at the security on it, we'll see that there's a WAF set up on here. You can see that within the topology, I believe, as well. Wherever that went, here it is. You'll see the WAF, like here's the full flow, right? And then if we look at the logs, we'll see that that one didn't work. I typed it wrong, but we can see historically, here was a flagged response. So if we look at the log detail on it, we come in, the WAF essentially flagged this. I don't have it in enforce mode right now. And we'll be able to see the full WAF signature of the SQL injection attack here, right? So that's all happening because I've wired up the WAF policy natively. I did all this through GitOps, by the way. Like the WAF policy is just an object in Kubernetes that I attached into my gateway coming in. And that allows me to block kind of any unknown signatures, attacks, et cetera, coming into my application. And then I can enforce all the restrictive traffic within the cluster here. So that gives you kind of two layers of security there. And then the last little bit here that I'll layer in is we can also, with this setup, put in an entry egress. Entry egress allows us to define an IP or from an IP pool for outbound traffic. So let's say this app wants to egress out of my cluster, but I need to give it a dedicated like exit point so that I know what it is when it's leaving. Because this isn't just
This
a
tends to
native
be
thing.
huge. Yeah, this tends to be huge when you have like a database that doesn't sit in a Kubernetes cluster, right?
Exactly.
Like you're having to get to like that database has to understand where traffic is coming from, right?
Exactly. So you have a database, and traditionally what you do is be like, hey, I've got an IP here, and I'm going to go to my traditional firewall and put a rule in place to talk to this database. You can absolutely do that because we're creating a known deterministic IP for a container's egress through entry egress. But also what's really cool about this with this vdefend integration is this egress actually shows up here. inside of vDefend, which means we can use it as an object for distributed firewall. Meaning I can say, I want this communication here to have a specific DFW rule in place to allow that. So I can actually do container to VM policy within vDefend now using this setup, which kind of ties it all together where now you're able to do security kind of at all layers through your networking stack, to be able to do east to west traffic, containers to VMs, and also WAF policy coming in at the layer 7 layer.
And
So
this tends to be like where nobody else can play in this space, right? Like VCF is like ESX basically ran the entire world's applications for 20 years. So there is a significant estate of applications, traditional applications that rely on traditional kind of architecture patterns, like what Will just said. Now, the difficulty is how do you modernize that stack using a unified set of solutions that allow you to handle all things like automation security for your entire estate and not segregate them into like here's my modern stuff, here's my traditional stuff, right? That's not how reality works, right? Your modern stuff has dependencies and things that your existing workflows need, and our product portfolio is designed to kind of marry those worlds together and make it such that one team and one set of skills can manage your entire application portfolio agnostic of like when they were developed and what best practices or not you're following.
and I think we're at time here for this session. So
I think so. We also like we totally didn't talk about like the basic NSX stuff, basic, but like VPCs and all that kind of stuff. Like that's also additional layers of security outside of the Kubernetes layer, and that enhance your overall security posture when it comes to VKS itself.
yep.
Cool.
So
But thank you guys so much. Again, another incredible session building upon the last one. We'll send everyone back to the lobby and join you all in, it looks like 8 minutes to start the third and final portion of this Kubernetes build. Thank you again. See you all soon.
thanks.
Thank you.